Come on, what do you guys think? AI? Come on, woo! Let's do it, let's do it. All right. Oh man, that was a great introduction. So I'm not sure I can actually top that. We should just call it a night. Let's go have some iftar, let's do that. So I'm here to talk to you about AI. It's a cool thing. It's called artificial intelligence. And it's super scary. It's super complicated. Nobody really knows what it is, especially me. I have no idea. And but basically, we're going to go through essentially a practical how to keep your laptop alive. Give it a second here. We're back there. All right. So, but basically what we've done is we've worked with Symphony for about 4 years and on a project called AirProxima, which I'll get to. So we've actually kind of gone through something I did at Amazon where you just practically go through how do you do something that's pretty much impossible. So just so we cleared, Jeff asks for the impossible. And yes, that's Jeff Bezos. He's a great guy. He's awesome, super bright, but he kind of asks for everything. I'll explain that later. So let's get started. So we already know that I'm a really great guy. We already heard that, which is nice. We kind of start the relationship that way. So I've been doing this for 30 years, been creeping around the industry, doing all sorts of stuff. One of the things I like to kind of point out to people is if you've ever used, you ever looked at YouTube? Maybe? YouTube? A few? Vimeo? Anybody? Anybody? Come on. Okay. So you probably have looked at my technology. So some of the stuff that I've done in the past is to build really scalable systems and go after new technologies and to kind of really change how we actually interact with our worlds. And so Amazon Alexa was one of these really big ideas that Jeff had. So I'll talk to you about that in a minute, a bit more. Netflix, I ran device security for a while. So you guys, your TV, when somebody tries to hack into that, it doesn't just say, hey, if you want to watch your TV, pay me $10. Right, so a lot of cool things like that. I'm also older than I look, so I always tell people that too, just so you know. When we go out partying later, just remember I'm old. So I used to work on mainframes as well. And kind of taking a look at all of this together, right, is a story arc where I've gone through multiple times finding things that should exist, that we want to exist, but they don't for some reason. And so part of this lecture, and part of this discussion, I should say, is to go through and explain how do you do that. So I'm working on AirProxima as we talked about. Oh, actually, I got this little clicker thing here. Technology. I didn't invent this, by the way. This is not mine. Uh-oh. Ah, wow, this is kind of clever. All right, hey, so here's the thing. I'm a super transparent guy. I'm going to tell you everything. Absolutely everything. Well, okay, not everything, but most everything. So I'm going to tell you how to win right off the bat. So you guys do this, you're all winners. Okay, probably winners right now. So see the big picture. If you don't have a really, really lofty goal in your life, if you don't know what you're shooting at, you got to have something kind of crazy big that you may not actually be able to do. That's a key to success, is don't think small because you will actually be able to do small. That's not a problem. You guys are all super bright. So don't think of it like that. Think of something you can't do. Like Amazon Alexa, right? That didn't exist. That was super impossible. But that device can now hear you 30 feet away. It can hear you downstairs, right? That crazy device because we knew what we were trying to do, and it was a lofty goal. So the other thing is biasing for action, and that's a phrase from Jeff. Remember Jeff? You guys all know Jeff now, right? So Jeff is a guy that comes up with a lot of rules to simplify our lives. Bias for action is all about do something. Don't wait. Don't overthink it. And my team over there, they're going oh, that dude overthinks everything. But it's, seriously though, you have to kind of take a big problem, pull it apart, and start working right away, because that's where all the learning is. That's what you're actually going to excel at, right? And if you think about the next phase of what I just said there is delivering something. So when you have a customer and you don't give them software, well, they don't use it, right? But so you give them software, they use it, and you know what they tell you? This sucks. And they tell you exactly what they want it to do. So part of this whole kind of key to success is the bias for action and delivering results. And you follow that up with iterating. So you have to keep going through this quickly. Don't wait. Every month you wait is a month that you haven't actually got more feedback and actually delivering the results that people want. Another thing that Symphony has been really, really helpful for me, but also I have 36 patents right now. I think there's more actually coming, and at some point you realize that it's kind of a crazy system there. But innovation is all about looking for the green crystals, and probably none of you are old enough to remember this, but there used to be a commercial for detergent, for laundry detergent, and it was sold for an extra 20 cents than the regular stuff, and they had these green crystals in it. And it was the super thing that made it better than anybody else's. Guys, there was nothing in the green crystals. It was just little green crystals in the damn thing. But there is technology that we do make that is unique. Always look for the unique technologies, because that's actually where the innovation really, really comes from. This is actually now part of the presentation, though, for AI. This is super critical, and it was incredibly important for Amazon, right, for Alexa, is you have to get the unique data. The person that controls the data wins, right? If you can have the best technology in the world, but if you don't have the data, and somebody else does, they're going to eventually eat your lunch. And of course, I like to eat lunch, so we got to work this out. Laptop. You know, the other thing that's super useful, though, just to be totally blunt about this, because I'm really not that smart. You know, I might have nice hair, but that's about it, right? You remember Jeff Bezos? Really nice guy. Reed Hastings, my first startup company was his first startup company. Now, he was a CEO. I was just, kind of a peon. But Reed taught me a tremendous amount about being an entrepreneur, right? And living around people and working with really, really fascinating people that are doing cool stuff, like here at Symphony, right? I would just give that to you, is it will lead you to other steps in your career and to find more people that can be mentors, right? That can train you, that can teach you things that you don't even know you want to do yet, but that you'll watch them, right? And like the bias for action kind of crap that comes out of, not crap, it was good stuff, comes out of Jeff's mouth. But the stuff that would come out of these people's mouths is just like, wow, blows your mind. So, of course, gets to the point where I'm drinking, wine in Mallorca, but that's a different scenario. We'll talk about that later. Uh-oh. There we go. But really, after all of that stuff I just said, it's about the team. Look at you guys, right? This is actually what makes it work. If you don't have a good team, it doesn't matter how good you are. You only have two hands. Your brain's only on like 25 hours a day, right? Everybody? No, okay, mine's off for you, a lot more than that. But having a great team around you and learning how to build teams was a great thing for me to realize from Reed Hastings way back when. Build the team first, and actually have a culture of folks that can build up a team with you. So it's a super important part. Now, I've just told you everything you need to know pretty much to be an entrepreneur. Who wants to do it? Oh, come on. Really? Okay, it was a simple question. All right. So let's talk about AirProxima. Who knows what a private jet is? Okay, yeah. You guys are like, oh, wait a minute now. Let's break the ice a little bit. Raise your hands. Everybody. Not a question. Thank you. Dear gosh. Come on. Okay, so private aviation is a really cool thing, right? You get on a private jet, they bring you the lobster, a little champagne. It's super nice, you get the red carpet treatment. Okay, so we decided to make a company that was basically going to do private jets just like you do Uber. So why can't we just go get on a jet right now? And why does it cost $40,000, US dollars, by the way, to fly? Well, this company that we built is addressing those issues, and we're going to go through kind of what were the challenges, why is AI kind of the reason that we actually are going to be successful? The smart people in the industry, how come they couldn't solve these big problems, and how couldn't they, make a service that, like Uber? So let's jump into it. So the first thing we should do is, as I mentioned before, everybody has a different opinion about what artificial intelligence is. Everybody, right? All, the folks that I work with. And remember, everybody I work with, they are definitely smarter than me. They have better definitions. But I'm going to offer you one that people like myself can remember. If you think about what artificial intelligence is, it's like kind of anything that simulates what humans can do in terms of intelligence, thought, and basically kind of how we learn. So if you think about that, that kind of covers a lot. So it's, it could be some math algorithm, like Laplace transforms or something like that. These things can approximate because it's a process. It's kind of like simulating what we would do as a mathematician. So we can do that with software. We have expert systems. We have algorithms, which is what I was kind of just talking about. Things that kind of get to a result with some inputs and some outputs, right? Machine learning is the buzzword. And actually, does everybody kind of know the difference between machine learning and artificial intelligence? If you raised your hand, I'd say you're a liar. I'm joking. I wouldn't say that. But really, machine learning is yet another technique to simulate how we think and, kind of approximate these things. Speech recognition, obviously, Amazon Alexa. You look at computer vision. These things are trying to simulate what humans can do. And so I'm going to rope all this into something that can go into artificial intelligence. But these guys are just a piece of it. So we focus very heavily on machine learning and the techniques for getting a result, right? But that's not sentient. We, by the way, everybody right now, if you're looking at me, guess what's happening right now? You have a bunch of sensors going on. You got your eyes, you got your ears, and even if you're not listening to me, you're still hearing me. And it's going into your brain. Your brain is processing it right now. And so the key thing to remember is that's not just an algorithm that you feed a little data to and get some output. Your brain is processing and taking action on what I'm saying. When I look you in the eyes, you look at me, right? You know, it's this thing that happens with our brains. Getting a computer to do that is super hard. In fact, I would actually argue probably hasn't been done yet, except in some lab somewhere that we don't know about, we probably don't want to know about. So let's go to, whoops. Uh-oh, there we go. How about a practical example, right? So if you think about what machine learning is going to do, machine learning is going to look at this picture and say, hey, that's glass, right? Maybe a really good one might say, that's kind of like beer. It might be because of the bubbles, because of the foam. It might actually, kind of intuit or infer that that is actually a glass of beer. However, an AI, on the other hand, is going to know that this is a glass that was designed for beer. It will infer a lot more context around that. It's not just a pattern match that this is a glass, this is maybe beer because of the color. But it might actually know what it was designed for. And it certainly would guess that I'm going to have one of these after the presentation, right? That's what AI does, as opposed to just that simple thing. So now you guys are all experts, right? Okay, well, let's keep going. So the other thing to think about is like algorithms versus machine learning. And this is going to be very important because you might ask yourself, why those people in the private aviation industry haven't succeeded. And I can tell you why. Again, I'll tell you everything. Very transparent. Super smart people, lots and lots of money, billions of dollars, right? And what they're doing is they're writing algorithms. They write code. They solve problems with software. It works, right? I mean, Google Flights is there, all the good stuff is there. But when you think about computing pi, right? It's a series of steps. And it takes as long as you want. Like pi is infinitely repeating. So it would be something that takes forever to run, right? So we have to approximate things with software, right? But it takes a certain amount of time. The difference, though, when I ask somebody, what is pi? You guys get it. Now, you may not remember that it's 3.1415926. And I don't remember that either. I just did the slide. But the cool thing is you infer this when somebody says, what is pi? And it's immediate. So in software terms, right, an algorithm that takes an hour to run, it's over in milliseconds or microseconds to infer something. Now, why is that important? Well, one of the big problems with the industry that we're talking about, private aviation, is they have so much data and they don't have these kind of techniques for machine learning and whatnot. They don't know how to do that. So they've written software that does optimization. It tries to figure out, hey, we've got all these bookings. The people want to get on these private jets. They're going to pay $20,000, $40,000, $5,000, whatever. And they optimize this through software. It takes forever, right? And so it takes so long that they don't want more customers, or they can't handle more customers. So if you could infer a lot of these understandings and all this stuff, then you could go a lot faster. You could optimize things in seconds. And actually, that is literally what we do. So we actually, in real time, Cannon, take a bow. So in real time, all the time, when schedules are changing, millions of bits flying around, we have software that is running and figuring out the optimal place for those planes to be. And I'll get a little bit more into this, but just keep that in mind that inferring is super fast. You do it in a heartbeat. You do it in an instant. But if I sat to, let's just do some math together, it'll take what it takes, right? It's a procedure. All right, so what do? So basically, we massively improve fleet logistics, right? Who cares? Well, the people that are customers care a lot. They'll save like hundreds of thousands of dollars. So they take their existing systems, the brightest people on the planet already, run our software, you get $200,000 a month back. Pretty nice. And what we're really trying to do, though, is we're trying to get those prices, we're trying to get the logistics down to something that I'm going to say we, because I don't want to spend $40,000 on a flight. Who does? See, now when you keep your hands down, it's good, right? So, but remember, I don't want to do that. And the cost of the aircraft is not that high. So there's all this inefficiency that drives those prices up, not just greed. So what we do is we're trying to get to the point where we're going to do Uber for private jets. And the only way to do that is to drive all the costs out of the system. You got to drive it, down to what commercial airlines do. Commercial airlines tell you which airport to go to, they tell you when to go there, and they charge you a ticket well in advance, and the schedules don't change. I don't like that. Do you guys like that? I hate it. I want to say, I'm going to go right now to Las Vegas and let's party, right? Right? You guys don't know Las Vegas. Okay, but it doesn't matter. But, sorry, it's a little too much context. So just remember that what we're trying to get at is something that is, it's a very big data problem, and it's very complicated. Can't do it with algorithms, but you can start with algorithms. So let's talk about, again, what I was just talking about. So the industry that we're talking about is $30 billion. The numbers are big, right? Commercial aviation is about $260 billion. So just the little private flights going around, lots and lots of money. But when you realize, and we realized this after we did all the work to look at the data, 40% of all the flights going around in the United States had nobody on them, except for the crew. Got to have the crew, pilot and everything. But nobody on them. Well, remember, it's like I told you, $40,000, per flight. Well, we can probably whip that right in half, because why don't we just put people on all the planes, right? Well, it's a problem, but that would be one of the solutions, is get rid of the inefficiencies. You want people to be flying. Don't move the planes if there's nobody paying for it. It's kind of crazy. The other thing is, because you're paying $40,000, guess what? You're going to probably have a pretty high, feeling about like you know what? I'm going to just book it when I want it, right? So 50% of all the bookings for private aviation happen within 3 days. So that means they don't have a whole lot of time to plan. And all those people with their abacuses and they're on the papers and they're trying to figure out the schedules and who's going to, totally impossible, right? Because people just call up, 2 hours beforehand, I'm going and I'm bringing my dog, and it's like, okay, $40,000, sure. You want lobster with that? So yeah, it's kind of a crazy industry. So the other thing that is not obvious, we detected it in our software. And I'm looking at you guys. That's right. Yeah, they don't get off easy, right? Talk to these people. So 60%, like almost 2/3 of the schedule for a day of flights will change that day in the morning, or sorry, over the course of that day. So they start that day with a beautiful schedule. It's nice. And then people call and say, oh my gosh, I'm going to be late, or hey, you know what, I got my aunt coming with her 3 dogs and I need more lobster. And I mean, things change. Now, every single time they make a change, it costs them money. And guess what? Remember, we're flying those planes around with nobody on them? It could be $40,000 cost to the person that owns those planes, that is running them. So they don't want to have change, because that's an expensive thing. And they can't go back to the person and say $80,000. They'll just say, we can't do it. You got to be here on time or whatever. So it's a bad experience for everybody. So that $40,000 is what actually drove a lot of the understanding of the optimization engines and things that we built. And if you take a look at the overall market now, it's not just 1 or 2 or 3 companies that do this. It is hundreds and hundreds of companies. And they're all competing with each other. And it's a long story about how this all works, but the truth is it's very fragmented. When you call up and say, I want to go whatever, somebody's going to go, 40,000. Somebody else goes, 10,000, 3,000, right? Well, what is the actual price? It seems a little bit like I just want to keep calling people until I get down to the price I want. The reason is they don't actually know, right? They don't know where the planes are going to be, right? They just, well, it'll be, you carry the 2, whatever it is, 10,000, right? So what we're bringing to that whole thing is algorithms that actually straighten it out. That's the first thing to do. But also what we do is we apply AI, because just like Amazon, remember? Amazon's a big thing. Jeff, remember Jeff? Yeah, okay. He's a great guy, just so we're clear. So Amazon put the packages where they were supposed to be before people ordered them. Seems kind of obvious, right? Horribly complicated. But why don't we do that with planes? So that's going to be the net of this talk. So we have this AI that I've affectionately been calling Proxy for a long time. And the team actually told me recently, they're like, oh, you named it. I'm like, well, no, it's been named like that all along, but we don't talk about Proxy too much. So in terms of her name. But basically, where do the people want to go and why do they want to go there? Because if there is basically like some cool rock concert or Ed Crump's talking somewhere, of course everybody wants to be there, right? So why do people want to go? Well, again, back to like big data, all this data exists. We have millions of records of events in the United States in particular. So from the bar fight that's going to be happening on Saturday to all the way up through Ed Crump talking at some stadium, right? So we have all this data, and we need to figure out where the aircraft need to be to match the demand. So before the people even think they want to go there, we'd like to make sure that we could have a plane that could be in the area so that when they ask for it, the price isn't $40,000. It's actually, we could do that for $5,000. Because we don't got to move the plane around to get you anymore, right? It's right where it should be. So the other sort of practical applications of all this stuff is the business is the way it is because they make a lot of money, but they don't earn a lot of money. So they'll make, we have one operator that will make $5 million a month. Nice, $5 million bucks. But they only get a couple $100,000 of that to use. It's just so inefficient, right? So the business actually has to go through and optimize all of that. All right, so just to give you guys a little bit of context on this, I mentioned to you algorithms, machine learning. So the way you do this is you always start with the algorithms. You always start to model things with software or something, because you can't do AI, you can't do machine learning, you can't intuit or infer things if you don't understand it yourself. Right? And that would be true for computers just like us. So the first thing to do is you have to go in and solve real problems. So first thing we did is put the planes where they're supposed to be with algorithms. And we can save people like a couple $100,000 a month just with better algorithms. Now those algorithms aren't perfect. They actually are not very resilient, right? There's, if Kennan's like laughing his ass off because there's so much, if the data is crappy, then, the algorithms they're crappy, right? And machine learning is actually better for this. But we can go from like a 15%, savings up to like 30% just by adding that one little thing. Like if we knew there was going to be a flight on Thursday over here, then we could put the plane there and we could actually save them even more money. So algorithms, 15% maybe, 30% when you add AI prediction into that, pretty big gain. So that's why all this crap I'm talking about is kind of important. So the other thing is we can take a look at the accuracy of this prediction. And so unfortunately, Ada's not here. She actually missed my presentation back in Belgrade. She's one of the ML engineers we have. But she was able to get, and Adian as well, we were able to get 90% accuracy on like figuring out there's a flight on Thursday, and it's going to be, out of Santa Monica over to, Las Vegas, and this person's going to bring their dog, and they're going to want lobster, and then they're going to basically want to be 15 minutes late because the Uber is 15 minutes late. So all this kind of stuff becomes the predictions that we can do. But the 90% prediction is we can actually predict where, what's the likelihood of this actually happening so that they can put that into their systems and they can actually put a plane where it's supposed to be. Again, when we look at how you do this, I mentioned to you earlier that the data is the key. So we have over 50 data feeds, and again, Kennan's laughing his ass off because he's been owned by this, because you have to ingest all this stuff, and it's horribly, it's incomplete, it's broken, it goes away once in a while. So we got 50 different real-time feeds that are coming in, but it covers essentially like huge amounts of data from ground transportation, events, lodging. I mentioned all this stuff to you guys. So that's a key, and you do that first. So if you're going to go build an AI, go get the data and understand the data. Go build the algorithms, because that all will create more data, and that becomes that defensible thing that we talked about. So we also, you have the opportunity when you're an entrepreneur, because you can go like influence people, talk well, So we did a partnership with a company called Degatech, and it's an example of a partnership where they just broker fuel for these aircraft. They do like $1 billion worth of trades, a year. They make very little money, a few $1 million out of that. But guess what they had? The data. They had no idea what they had. And I said, I tell you what, I'll give you some money. You just give me your data. Just maybe a little bit, like exclusively to me and nobody else. And they said, money? Sure, right? Because I give them a few $1 million. It's like, hey, we make this kind of money. That's kind of how much money they make anyways, right? So they had no idea what they had. You look for that as an entrepreneur. Find those things that nobody else cares about that is super valuable to you and get it, right? We did that with Alexa, right? We did all sorts of things to gather data for Alexa, because if you remember Alexa, right, we couldn't show it to anybody. Super secret. So the only way to train an AI is with a lot of data. How are you going to get it? I built rooms inside of secret buildings that people would walk into and have breakfast. They would turn on the fans. They would do all sorts of things. They'd run the the dishwasher. They would do all sorts of stuff to create environments which would be much like what we would do, when you go home and whatnot. We rented houses, and I would put 40 or 50 of these Alexa devices hidden in the house, right, all over the place, in each room, right? People would come in there and we'd say, hey, I'll pay you $10. You read this. Just read it, and I'll ask you some questions. Walk around the room. Hey, Ed, how you doing? Oh, I got great hair. It's pretty cool. And what do you guys do for a living? So the ability to collect the data was super important. Turns out Tegatech has 40% of the industry's data about where they're flying. 40%. That's insane, right? So of course, for a few $1 million, we're winning. So moving right on. One of the things we talked about was predicting the number of aircraft required for a route. Turns out that, the day after, the weekend after Thanksgiving in the United States, they need lots and lots of planes to, bring people home. This is one of the biggest problems that these guys have. And what they do is they could take like $10 million and they go rent everybody else's planes everywhere. They get all the planes they can, right? Because they don't know how many planes they need. And so some of these operators, they have already sold the flights. So they can't not do it, right? Back to that $40,000 problem, right? If they need to go to somebody else and they haven't already done it, could be a lot of money to those guys. So what we did is we said, look, why don't we produce an API for them that they give us some information about what, when the day is, what the route is, and we're going to tell them literally, we're going to tell you by the hour, the route, so from A to B, right? And the aircraft class. Do you want a turboprop? Do you want, you want fries with that? Do you want is it a jet, light jet, whatever? And so with algorithms, the baseline predictions, right, we were able to get 90%, kind of accuracy. Just the baseline predictions with the ML models. So this is back to the team taking the data, crunching it, really good accuracy. But the thing that actually for AI makes a big difference here is being able to bring in other data sources that don't make any sense. So what we did is we said, hey, look, Airbnb data, right? How does that relate to private flights? Well, maybe it's where people were coming from or going to. So we took Airbnb data in New York, right? So how many listings were there over the course of time? We got several years with the data. And then we took a look at some flights that would go from New York down to, let's say, South Florida, United States, right? And we were able to take a look at that Airbnb data, and there was predictors in there. So we could actually just take Airbnb data and augment what we were already doing to get 94%. So why does that matter? Well, back to that $10 million that they're licensing everybody's planes, now we can tell them exactly, with 94% accuracy, how many planes they need. So this case study was one that we went to the largest aircraft operator out there in the United States, and kind of the close to the world. And we were able to do something that they had never even contemplated, right? They're like, getting 90% is really amazing with ML. But we got to 94%, and we solved a huge problem for them. So that's kind of an example of this. Another one is taking a look at these, remember those dead legs, those 40% where nobody's on these planes, right? That's another big problem to solve. So we were actually able to say, why don't we just take all your schedules and monitor them continuously, right? And then look for essentially, the predictions we can do for future flights and then optimize ahead of time, right? So we can actually say, where should the planes be? So this was a case study where we were able to do that. We were able to basically, do, like I said, 15% savings, maybe $50,000 a week, depending on the operator in this particular case. But if we actually take a look at predicting now, doing a lot more with predicting where the flights were going to be, we're able to drop that or bring that up to 25% and $80,000 a month. So you take some of these, kind of base things and you add more data, you add more stuff on top of it, and you go even higher. So I've already kind of mentioned a little bit of this, but one of the things that for learning from Amazon was the data pipeline. So I mentioned that data is super important. It comes in all forms, and it is super important to curate that data, to basically clean up that data and get that data into a world that the AI can actually use, the ML models can use. And so the ability to get all that data, curate it into a form is the first stage for any AI thing you're going to do. So just keep that in the back of your minds. Whenever you do an AI thing, I was telling you guys about this earlier, right? Whenever you basically do anything with AI, you're going to have to get the data and do something with it to clean it up. And then you iterate. So every time you basically get new feeds, you have to keep going on this. You have to keep looking at the interactions between these data feeds. So that's part of the gig. The other thing about what we do as an entrepreneur and in this industry is you want to not only iterate fast, but when you go through and get data, you go test it with customers right away. You got to make sure that what you're actually showing makes sense, because the algorithms look really good. The ML models look really, really good. They may not match with reality. So the other thing that we did was leverage Symphony. So I would kind of call this out because you guys will be in this position potentially. If you're working at Symphony, you're going to be on one side of this fence. If you're on the outside of this as an entrepreneur, you want to find partners that can actually work with you on developing these things, that have the capabilities to do this, that have the, sort of the, I'm going to hand you a really thorny problem and be able to work with us on this. At Amazon, I was burning $50 million a year building out Alexa for Jeff. Remember Jeff? So he's a good guy. But he wants it, so you're going to do what he wants, right? And so, but we've developed everything that we have at AirProxima for about $1 million, a little less than $1 million. And so frugality is super important. So if you're going to go build AI and you don't have Jeff's resources, richest person on the planet, remember Jeff? But you have to do it somehow. So Symphony was really critical to our ability to do this over the last 4 years. And I mentioned to you before, it's all about the data. So if you actually don't get the data, just remember, Ed's out there probably watching whatever you're doing, and he's going to go get that data. So, get a little water here. All right. So we've already gone through, I mentioned building out the algorithms. That's the first place you start. Business logic, understanding private aviation, understanding the problems you're trying to solve. That's all been done. We did that back in 2017, and we actually have solved those big problems with algorithms. 2018, actually, we did something called supervised learning with machine learning. And what that is you basically take your data, you build some models, you build these things with some cool technology, but you actually know what the outcomes of those models should be, so you're training a brain. It's like you give it data, it's supposed to get this output, and when it gets it wrong, you feed back that information to tell it to do it better next time. We've got that. We've got that in spades. In 2018, I mentioned to you that we were getting 90% accuracy and above for all the test cases that we were doing with these partners. So that's already done. We've actually started working on the really kind of the dark magic here. At least I'm going to call it now. Adine over there knows more dark magic than I will ever know. But the dark magic is to actually do something where you don't actually start with the knowledge of what the answers are. And this becomes extremely complicated. And I'm going to get to something in a minute that will even make it worse than this. But with Alexa, right, when you get a lot of data, right, you can train, a model to like recognize words, right? You take the phonemes, you kind of burst them, take the words, burst them into phonemes, you kind of look up on the database, and it's all really cool. But what happens if that person has an accent? Like Ed. I got a crazy accent, right? So you need to be able to have some fuzzy kind of figure out that this is actually the word that person said. It might be because it's Ed speaking, right? So when you think about unsupervised learning and these kind of techniques that are more to the black magic, it is how are we actually training this thing, this AI, this machine learning stuff, to think for itself, to actually pull things out of the data that you can't see. Because remember, there's so much data, there's no way for you to do this yourself. I know I'm losing you guys. It's going to be like, so let's talk about Symphony for a second. So one of the, things is critical to find, if you need critical resources, you need critical sort of like specific AI people that come right out of school, that are getting pulled into a company. Symphony was actually there for top tier talent for us. They had the skills, they had the talent, and we could actually now scale with them. So as we did more projects, we could do more things. We could say, hey, I need to have another couple of engineers. I need to have another couple of ML people. So again, I'm kind of plugging Symphony because Symphony is actually somewhat unique. I've been doing this for 30 years, right? And it's you can outsource, you can find people that will do work for you, but to find people that actually can scale with you, that can actually be better than you about your core technology, that's very rare. And it was super important for us in our project. And also, having a larger pool of developers means that when you're talking to an engineer at Symphony, there's 200 people behind them. And we have used this to our advantage so many times. It's huge. And the other thing I mentioned, or I had it there on the slide, I will just mention that we actually take advantage of the fact that the time zone difference is actually super useful to us, because as I go to bed, the other team is waking up effectively. And so all those ideas that Ed had, all those crazy good ideas, then they have to go deal with it, right? And they have a whole day to deal with it before I get back up. And then it's always nice, right? Okay, by the way, you guys can laugh, right? Because it's true, right? It's pretty bad. So I'm going to go through some technical things because there's technical people in the audience, but not too technical. But remember that thing? There's something called a data lake, and that's where we put all that data, and that's where we curate it all. That's where we pull out all of the features, all the information in there that is something that will be used to train these models with. I mentioned that the data pipeline, super important. The ability to have a knowledge base of what means what, is super important, because you need to be able to train with information that relates to other information. So that's another big piece of this. The ability for your application, like on your phone. In fact, so when you have your phone, and I should have done this earlier, who has LinkedIn? Yeah, okay. Get your LinkedIn out. All right. Take a moment. When you go to your LinkedIn, right, there's a button at the bottom that's your people. And at the top of that screen is Find Nearby. All right? I'm leaving mine open so you guys can connect with me. So the ability for you to get data out of this and be able to use it in real time like that, you need to have this data distribution. So in real time, as you guys right now are clicking on that, it's showing up on my phone. So super important when you think about this brain that is constantly moving and processing data. That's a key piece of it. And the ability to take something that is being developed by, let's say, Adin's team, it's a model, but how do you put it into the software? Because these guys will spend 2 weeks building a model, right? But once it works, once it's better, you got to have a way of putting that in the system. I mentioned algorithms. I'm not going to belabor that anymore, but I do want to really hit back on the idea that proxy is something, the only way it becomes AI is if it's continuously running. And you can't just sort of feed it data and get an answer, because that's kind of more like what algorithms do, right? You want something that is watching the data, and then it says, oh, Ed, $100,000, right there on the table, get it, right? You want that brain, you want that kind of information being kind of pushed to you. With strategic partners, we don't have to tell them how it all works or what we're doing. We can just say, look, just put your planes here, you'll save a couple $100,000. But this is what we use as AI as a service. So now they can get these sort of APIs that just recommend what to do in their business. And the last piece that I mentioned earlier that I want to just bring it all home, and this is something that doesn't exist right now. If you think about how humans deal with things and how we look at our lives and all that input I was telling you guys, you see me up here waving my hands and one of that crazy guys, come ask for money or something, I don't know. But if you look at actually what needs to happen is to learn something, you have to recognize there's a problem. You have to have a goal, right? And you also need to be able to solve that problem. So how do you solve problems, right? When you think about it, I want to go get this thing done, you think all the different options, you go get some data, you go talk to friends, whatever it is, but you have to learn how to do that. What we're going to do basically with AirProxima is we're going to observe what happens. So I'm going to go save you $200,000, and here's your recommendations, and then I walk away. Okay? And then I watch what happens on the back end to those data feeds. Remember those big data feeds? Remember it's all about the data? And I watch what happens. And when you actually take my recommendation, because it's surprising, even if I offer you $200,000, not everybody takes it, right? Why didn't they take it? Observing the system outside of the AI, outside of it, seeing what the human behavior is behind that is actually a key. And being able to learn from these things that humans, we don't even know why people renting stuff in New York actually matters for the flights down to South Florida. But because we observe that, we can actually do something with that. We as humans, we're going to train basically Proxy to do that as well. Now, once we've done that for AirProxima, of course, now you guys have to worry about Skynet and all those things. And I'm really sorry about that. It was not my fault. Okay, maybe it was. So at the end of the day, this is the next steps, and this does not exist right now. Nobody, as far as I know, really has solved this. There's a lot of papers, a lot of great, bright minds. So maybe you guys, maybe somebody here in the audience is the people that are going to solve this. Watching you. So again, how do we do this, man? Innovate. Come up with these clever ideas, like I just mentioned. How do we solve something where machines need to learn by themselves? Prototype these things. Figure out like what is the simplest thing that you can do to demonstrate that you know a little bit about the problem, and then demonstrate it. With Jeff, I love that guy. Remember Jeff, right? He'd come in and we'd have these meetings. He'd be like, Ed, what do you got for me today? Right? I'd be like, we got something really cool. And then we'd review it. We'd talk about it. And he'd be like, awesome. He goes, what are you going to have next month? Right? Iterate, iterate, iterate. Prototype, prototype, prototype. And then engaging your customers, Jeff in this particular case, but Alexa, right, and AirProxima, the faster you get it into somebody's hands, the faster that they're going to use it and give you feedback. Again, that goes really important for data. The more data you can collect, the more I stimulate somebody to give me more data, the better we get. Delivering results, nobody's going to use your system if it doesn't work. And if it isn't solving a problem, nobody's going to use it, right? And then again, back to the keep iterating and then change the world. Go after something big and lofty, scary. Do things that your team is going to hate you for. I mean, hopefully not much, but. And that's how we make an AI. Cool. So this was a lot of talking at you guys. I did it purposely. I hacked your brain a couple times. You probably didn't realize it. Remember, security at Netflix, just so we're clear. But now you guys must have questions. So what do you guys think? Any questions? Have I terrified you? Come on. Oh, right. I forget, though. What was the question again? Once I get talking, I get excited. I forget. He was...
The first one was, how did you get to the place where you are now? So that's the first one, but the second one I think you answered to the opposite.
Cool.
About how we can do like you.
Yeah, you guys can all be better than me, okay? I'm just the guy with hair up here talking. So, how did I get where I'm at? I would say that I have a very strong passion for learning, and I have a very strong passion for building teams. And if you try to do the things yourself, you will reach a limit, right? And when I was younger, when I was 12, he wasn't joking. I mean, I was sitting there with my dentist, and I would sit in this dentist's office. They never turned on that computer to answer his question. They never turned it on. They bought it, tens of thousands of dollars, and they just hopefully it was going to turn itself on and do something, right? Okay, well, back then nobody knew about computers, right? So I had a passion for here's this piece of equipment sitting there not doing anything, and it could do stuff. And so all throughout my life, my parents were very encouraging of this, and I would find problems that were not solved, right? And mathematics problems, I try to, solve things that people hadn't figured out yet. And so what I would encourage you to do is, especially when you think about who you're going to hire, be curious. One of the things that Jeff really liked about me, maybe a whole bunch of things. No, I'm joking. But one of the things that he really liked about me is super curious, right? Totally unafraid. I was one of those guys in a room with Jeff where I'd be like, I don't know. And all the VPs around be like, he's going to shoot you. But no, I never got shot. And I want you guys to be curious because that's actually where the innovation comes from. And that lack of fear will drive a lot of that innovation, that iteration and whatnot. So, just kind of a way of saying, and then just keep going. So by the time I got, I would have told, I'll just tell you the story now because you asked the question. You guys are all terrified of me. So I never would have joined Amazon. I've had a tremendous career up to Amazon. Never would have joined them. I'm a startup guy, right? I do like small companies. I love building teams. I love finding really bright minds that want to do amazing stuff. So when I got tapped and basically said, you got to come run this thing for Jeff. I mean, it's super interesting. I'm going, no, I'm going to go do my startup stuff, right? Thank God I didn't do that. But the key thing was when they finally told me that, hey, look, you're going to work with people you worked with before and they believe in this, I took a risk. So take risks. I mean, think about it. What do you have to lose, right? Might be some money, might be some time, right? Take risks. And so I took a risk. My first day, I found out what we were working on. I was like, this is physically impossible. I'm not talking about Alexa. Alexa was a small thing that Jeff wanted to do. There's a bigger thing coming, right? Just so you guys know, it was a 20-year vision. There's a bigger thing coming of it. But that was impossible at the time. But we just pulled it apart. So iterate. Don't worry so much about if you don't know how to solve it. If you don't know, it's I'm like, light doesn't do that. Physics says light doesn't do that. Well, maybe we can figure it out. And we kind of did. So what other questions? Here we go. Yeah, no, that's so you're talking about for AirProxima, right? Yeah, yeah. So that's a really, really good question. I'm going to answer another question first to say that AI and ML models, as you probably know, I'm assuming that because you asked that question. So if you think about data, it's sometimes hard to know how much data you need, right? So we were very lucky because the largest operator in the world, and I guess I'm a very lucky guy, by the way, just very lucky. Largest operator in the world, they gave us all their data. I mean, I don't know. It's like, dear God. I mean, it was like 15 years worth of data. So it turns out we didn't need 15 years of data. We could do pretty good with 3, right? Now, we may have done more. If you guys, let's see, it's like two-shot, or there's a new technique for like using a few data samples to create more better AI or better ML models. So we could probably even go smaller, right, to the data sets. But we were lucky when we started with. That's why out of the gates we got like 90%. Because we had so much data. So normally, I think your question also, I'll ask another question that you were going to ask, which is, what happens when you don't have the data, right? Well, you need to go manufacture the data, or you need to have better algorithms that generate better models, right? So, that answer your question? Okay, that's actually another great point that I didn't bring up. So what she's saying is that basically what happens when that data is actually now it's outdated. It's actually leading you into the wrong sort of like, that absolutely is true, right? It just happens that the people where they want to go over the past 15 years hasn't really changed. So you're right that we were dealing with a data set that was somewhat consistent like that. It's a really good question. Well done. You get a beer afterwards. Okay. Anybody else? Come on, there we go. That's a great question. So my philosophy based on what we did at Amazon is you're always training. Always training. And so just imagine a system that's, you get the updates. So you have a data set and you're constantly getting updates for the data set. You then punch this through essentially something that is training models, right? And you're always having a list of these models that are popping out, but each one of those models you need to test against something. So one of the challenges we had at Amazon is that it's easy to say this model is better than that one by looking essentially, think of it like the mean, right? You can say this is 85 and this one's 88, so the 88's better, right? But, as you know, because I can see you nodding your head, but what happens if it's like 88% in the mean, but yeah, it could be like 4% accurate and 90% accurate sometime. You want something that is going to tailor itself to the application of what the model is supposed to do. So you might actually have a series of models that are constantly being trained and they're evaluated differently. Like we want this one to be in the mean of above this, but its standard deviation needs to be really narrow. And another one you don't care so much. So does that kind of give you a sense of that? So it's philosophically I burn a lot of money because that's happened, but generally speaking, that's something you have to contend with. Is you can't always retrain. There's not enough CPUs in the world, in spite of what Amazon and Google have been doing. But that's kind of philosophically, I would just encourage everybody think in terms of continuous training and testing because you want this automated and you want to understand when things get better why they got better. Cool. And you've been laughing. You must have a question. You knew I was going to get you, right? See, this is what happens. You love. Anyways, no question. Okay, all right. I'll leave you alone. Anybody else? All right. All right, you get a beer too. So basically, there's what we've talked about. I've only talked about half of the story. You'll find this out about me. There's always more. Right? Just keep asking, right? You'll find there's more stuff. So AirProxima, to get to Uber for private jets, right? You need a marketplace. You need actually the supply side, which is the aircraft. It's the aircraft people that fly them around, and all of that kind of infrastructure, the FAA. You need the airports and all of that. You also need people buying these things. Now, the good news is there are already people buying them. So I don't need to do any marketing. I just get a bunch of people in there. It's like I said, $30 billion a year. It's already there. But the question is extremely well taken because I'm not going to stop there, right? Uber, right? What do you do with Uber, right? What do you do with these on-demand services? It's like, I got my buddies. Let's go. Let's go right now. It's got to be on demand. What we are teeing up is quite literally this. So we will have AirProxima become a brand. So you think about United, Lufthansa, you think about, Air Serbia, right? They are a brand where you go to rent or to go get tickets. When you go there, what do? You say, I want to go from this airport to this airport on this day. But if you think about it, you type in I don't know, Sarajevo, you type in, Belgrade, whatever you're typing in. But remember, your brain has already been coached. They already told you what the answers are. They said, you can go from Belgrade. They limit your choices immediately, right? That's not super useful, but that's how that economy of commercial aircraft work. We're going to do something different, which is, where do you want to go? When do you want to be there? And then we'll pick the airport based on what you tell us, and we're going to stack rank them by price and by time. So how much do you want to trade off? You want to spend $2,000 and get there in an hour? Or do you want to spend maybe $1,500 and maybe it's will take you longer to get there? But it's more about what you want. It's not really what we want you to do. We're just going to find the best optimal solutions. So back to the question, when we get enough of this data, remember 40%? 2019, right now, we're going out to the operator network out there. There's 300 of them within Degatech's network, the guys with the data. Remember the data? Super important. So we're going out to all those customers right now. We're lining up the betas for these guys. They've been helping us all along. And once we've turned the crank on the 7, we're going to turn the crank on the 300, and then we're going to turn the crank on the consumer version. Because at some point, I have all the data. Nobody else has anything like this. So when I actually stand up this service and you guys go to airproxima.com, I'll give you a commercial flight. If you want to fly from Sarajevo to Belgrade, I will give you an Air Serbia flight, no problem. But if there is a private jet, I'm going to show you that too, right? And then maybe it's the same price. And you might just say, yeah, I want lobster with that, right? So that's how we're going to basically do this, is we're going to make it so super easy for consumers to find us. So it's a good question. All right. Ha.
How do you present yourself to customers? Would you rather go with what is AirProxima or why AirProxima?
Oh, wow. That's a great question. I'm impressed. I know, you got me. I was like, yeah. I've been doing this now for a while, older than I look, remember? So I actually tend to, get the motivation for kind of what we're doing. And it's like people that we talk to, it's like, why do you care about these things? So I think I generally find out why they will care. And then I talk about why we're doing this. We're going to solve an issue with private aviation that exists today. And we're going to basically change the world. So it's a great question because, I could probably answer that both ways.
But I prefer the why.
Yeah.
So I was really curious about your answer.
Yeah.
Because obviously I'm more experienced in
Yeah.
business.
Yeah. You're welcome. Actually, you made me remember something that I think it depends also on the customer or let's say the operators, the customers you're talking to, because some people, they don't want to talk to you, right? And so if you go in there and say, I'm going to change the world, I got great hair, they're going to be like, go away, right? But, which happens, just like that, right? But sometimes it's like they just want to save money. And if you walk in there and you can save them like $100,000, then they're like going to be, okay, well, sure, show me it. Oh, it actually is real? Oh, wow, okay. And they don't want to know why you're doing it. They don't want to know about why you want their data. And in fact, I've signed a lot of deals where I get all this data and they don't know why. So I think you're right that I generally go after why, but the what is actually can be very important of just saying, hey, optimization software, you can just license it. Don't have to listen to me. Don't have to do the crazy hair. It's all good. It's a good question. Thank you. There we go. Thank you.
You have mentioned a large amount of data arriving from multiple sources. First, through your reasoning process, what kind of architecture design that you prefer to work on this data? And second, it's not easy because the process of this machine learning is not really standardized yet. The second, what was your technology stack to both manage algorithms as well as service?
No. I'm forming my thoughts. So my first answer is yes, but that's not very helpful. So I'll maybe go backwards, I think. So the tech stack that we used, it's all Linux-based. I've been doing this for 30 years. So Linux is a simple way of scaling out your business. It works really well with things like AWS, Amazon services, Google services, containers, another thing that you can kind of imagine that works really well for that. So the tech stack would be something very simple. So for the algorithms and for the software, Linux, like Mongo databases, so specifically databases are very flexible, so you don't think so much about the data you're storing and how you get it out. In terms of the software, we wrote the software in Node, JavaScript. And again, I've done this enough times where you could write it in Java, you can do it in C++, you can do it in Python, you can do it in Perl. Did one of those, that was not a good idea. Sorry, I'm getting nervous. But JavaScript is an example of something that, it's a great way to iterate fast. And pretty much every developer out there that you're going to talk to has probably dabbled in it a little bit. So that tech stack worked really well. The team, I think what we've learned over time, actually, Kenan in particular, when we first started, we really didn't know everything we needed to know about the environment, so we had to learn as we went through it. But JavaScript and Node was a way to just get started, and you can pretty much learn it overnight. So that was an example of that. And now I've lost the other two questions. There were two more. Keep going. I knew that was going to happen.
While reading this data that is arriving from multiple research, what kind of architectural design do you follow?
Right.
How did you read this data?
Yeah, so take the first part of that first, which is essentially, how did we figure out what to do? So let's talk about the data that we're getting. And I want to keep, if you're thinking about AI and ML, think about it this way. Where are you getting that data? If a human was involved in that data anywhere, guess what? It's probably screwed up, right? There's probably something missing. It's like typos. We're all smart people, but come on, and we're not computers, right? Hence the problem. So the thing is recognizing where the data comes from. So what we realized is we're getting data that was extremely well formatted from computer systems, APIs, lots of great data. You can just take that data into your pipeline and it's very regular, right? But you still need to curate it a little bit. You need to maybe change some of the data, kind of transform it a little bit. But what happens if that data comes from an Excel spreadsheet or a Google sheet where somebody's literally typing that stuff in? We also support that because back to this industry that we're in, when we go and do a pitch to somebody and we say, hey, we'd like to integrate with your data, sometimes they're running their whole billion-dollar industry off of Excel spreadsheets, right? And you don't laugh, you go like, but you got to get that data in there, right? And so we've developed systems, right, to basically take that data knowing that it's bad. Okay, so now what I'm talking about in the original slides, or I probably can even find it, maybe not, the data lake. So you guys should have the terminology that we're using for this is you can take data from anywhere. There's really two kinds of data that you think about. There's structured and unstructured data as a way of looking at this. There's like, you look at an Excel spreadsheet with columns and rows, that's very structured data. You look at a book, with pictures in it, that's kind of structured and very unstructured. You look at like somebody's emails, it can be very unstructured, what's in there and whatnot. So your data lake needs to be able to handle not only where you got it and how it was generated, but all these different formats and these kind of, formats that are completely ad hoc. So that was the first thing that we realized, that we needed a data collection layer. So if you think about, I'm going to draw you a mental diagram, should have had one on the slide for you, but data collection is a very complicated thing because you're getting it from all these sources. Some are being pushed to you, some you have to go get. Some are just randomly out there like in a Google Sheet that you have to go out and take a look at and decide if anything's changed. Right? Who touched what in there? Because maybe that's important, maybe it's not. So that data collection layer tends to be a fairly complicated thing. I've been doing this for 30 years, so it turns out that this is something that other companies I've done, we had to solve a similar problems about how do you curate and get data into your system. So that's a key piece of the architecture. Another key piece of the architecture that you have to kind of bite off is that since you've collected this data, you're going to need to transform this data. And in the world of computer science, you're going to hear things like ETL, enterprise, transform and load, and things like that, whatever. But the point is the ability to take that data and put it in a form that is useful, because maybe some comes from the Google Sheet, some comes from this API, and some comes from your own algorithms. You need to pull that all into something that is now structured and curated and essentially transformed. And then you have like a clean data source, which is essentially now used for the rest of the system. So you can use the raw data, you can use these curated data sources. So I've got 2 big blocks now. And then the third one, which is super important, again, everybody screws this one up because it's not obvious, but you need to find a mechanism to take this, you look back into this data lake, you look back in through the pipeline, and the application may want to have curated, transformed data, really clever stuff, or it might want to go right down to the Twitter feed that you pulled and pull that person's tweet. Completely unstructured, completely random, right? But the application may want all of that data for whatever purposes it needs. So you need an architecture that distributes data and publishes data in a very systematic way. So there's your 3 pieces. And now you know everything. I told you I'd tell you everything, right? Other questions? I think you were Alexia.
So you were constantly retraining your process. So when the data runs, how do you know if that runs, for example, has happened some exceptions? So how do you can rule them out or use them? And also, like, you can't predict that for Thanksgiving it's gonna happen bigger, more bookings than that.
Mm-hmm.
But what about some events that are not annual, like Olympics?
Yeah.
Handle that?
That's a good question. Actually, since Olympics are kind of regular, I would kind of categorize, yeah, but that's okay. But no, it's a great question. I'm actually, yeah, that's right. It's different things. So I think maybe categorize what you're asking me. There's two parts to that. One is sort of like dealing with the fact that you have anomalies in the data and recognizing that. And part of the curation process and the building of models kind of takes that into account. So what you can do is you can build models from data sets so that you purposely are getting the data, the signal out of there, but you're also potentially getting rid of the things that are anomalous and not really helping. So there's a class of things there with the regular data. But there's something else you can do, right? So when you have, let's say, the weekend after Thanksgiving, I can write a program that will forecast the number. And it's accurate within a certain tolerance and whatnot. Machine learning, I can do the same thing. I can build a model that takes the historical data, right, and then can predict essentially what the, how many aircraft you're going to need. But I can do something even cleverer, which is what the team did. And I mentioned that Symphony has been ridiculously good about this kind of thing, brainstorming with me on how do we actually solve these problems. You can now take a look at the data and go after some of the things that are not obvious, like not regular. Turned out that March 7th, what happens on March 7th, guys? Anybody? Boom! I like you, right? That's good, man. Here, give me the headset. You just do this, man. So guess what? March 7th turned out to be a 90% predictor for the number of flights that Thanksgiving. So to your point, every Thanksgiving is different, but the March 7th before the Thanksgiving, the weekend of Thanksgiving, was a predictor. So we were able now to say, well, part of the signals we can get out of the data is what's happening on March 7th. Now, that's an example where in AI and ML, we have no idea why that happened. I mean, we just found it in the data, and there was actually 5 or 6 other dates in the US, kind of calendars that we could say, hey, these dates have, percentage predictors, and we can then use this to go from, like I said, like the 90% to 94% accuracy on things. So, but when you know that March 7th is actually somehow meaningful, is that a bug? Is it real? And so you then start to say, well, one of the things that you might want to find out is, well, it's travel. Where are people going? And then you start to figure out, oh, it's a weird thing, but earnings reports coming out like in a week, over the next few weeks. And then you realize what's actually happening potentially, because you don't know, this is human beings that react differently. And I might want to stay an extra day and I want to leave Monday, and other people that have to go to work Monday, have to leave on Sunday. Human behavior is complicated, right? Especially when you have millions of humans doing it. So the March 7th, though, we looked forward and we found a bunch of reasons why, right? Now, did we do anything with that yet? No, but it was an anomaly. So does that kind of give you an answer to that question about how that goes? Did I get all of your question? You'd be surprised. I'll keep talking, right? I will. These guys are like, yes, he will. So, guys, you had a question over here.
It's a simple question. So how much will it cost? It could be the cheapest flight.
Oh. Okay, this is great. So this is great. I like that, right? By the way, remember the LinkedIn thing, right? It was open. So who do you think I'm going to like be taking with me on these private flights? Just do it. I'm just saying. I already warned you. So okay. So here's the thing. So one of the key things about what this costs, and this is why it's complicated, right? Is an aircraft is dominated by how much fuel it burns, right? The price or the cost of the aircraft. You have pilots that get, a certain amount of money. You get staff. You get, landing fees. All sorts of things. But it's really dominated by the fuel. And so, but when they fuel up, where they fuel up, how much the fuel it costs, that's why we actually are doing this deal with Degatech. Remember those guys with the 40% data? It's all about the data. Jeff, data, remember? Just remember those things. You're going to win. So getting back to your point, what is the cheapest that we can get to a flight? The answer is actually 0. But the aircraft I just told you is going to cost a certain amount, and it's going to be based on how far you go and the class of aircraft. So generally speaking, a turboprop might be $1,250 an hour. A light jet might be $3,000 an hour. A heavy jet might be $10,000 an hour, right? But you get the lobster, you get the bed, you get the shower, and you get to go to Italy with that, right? Or for you guys in particular, you get to go to the U.S. and see me in California, right? So to your question, though, the reason that it will be 0, and this is back to the question of the consumer thing, is because remember the 40%? Guess what they do when those planes are flying around empty? Well, they charge the person that they flew back previously to bring the plane back home. So when you go to them and say, I want to go from here to here, they say, okay, that's $10,000 engine time, for the fuel and whatever, and then we're going to charge you $10,000 to get it back. So now we're at 20, but the plane is probably going to be over here somewhere, so we're going to charge you 35. Right? 35, 30, okay, 25. They do that kind of crap, right? So, but what happens when they're flying a plane back that's already paid for? Then we can be 0. So there you go. Okay, well, you get $3,000.
I understand the supervised learning part, how you apply it to generate those predictions, you have to input the output into the training. You mentioned unsupervised learning at one point. I'm just not sure which part of the system is unsupervised learning training, or which sub-problem, concrete sub-problem. The supervised learning is okay.
Yeah. March 7th. March 7th. So, boom! Now we know! Dude, if I'd only known you before. Wow. Yeah, yeah, I should have predicted he was going to be here tonight. I failed. So let's talk about tech for a second, and this is where, Adine, just got to close your ears because I will lie to you a little bit. Not because I'm mean, I'm kind of not very bright, but I like to think in terms of simple answers to things, and then we can always get more complicated, right? So there's something called principal component analysis, and it's a very fancy way of saying kind of looking for features and looking for sort of the components of the data that actually matter the most, right? So when you look at you take Alexa, and you take all of the kind of the signals that come in there, the words, et cetera, right? But if you actually kind of look through the data, there's actually patterns in that data, right? You don't even know why the pattern's there, March 7th, right? You don't know why the pattern is there. But what you can do is recognize that there is a clustering or a pattern in there. And then what you can do is take that and you can take advantage of the fact that it's there, and then you can draw essentially inference from what that means and wrap it into something that is concrete for you. So the machine never understands why, right? It doesn't care. What it did is it gave you a cluster. It gave you a signal, right, that you can then use for whatever purpose you want. And so again, I could, basically have Adine give him the headset, and then he could explain why I just lied to you, and it's terrible. But the point is that it is something you can do that means you are not annotating the data. It's like a flight from San Francisco to LA at 13:50, right? I know that that's what the flight is, and so I can actually, when I'm doing predictions, I can compare what it should have been, and that's called annotation. You take the data and you annotate what the output should be, what the result should be, you kind of record that. But what happens if you don't have labels? So you need to be able to take this and give it sort of a goal that is not based on you telling it what the answers are. And so this is back to, getting further and further on this. You guys work together? oh, that sucks, right? You got the experts right over here going like, dude, right, I got you. No, anyways, but that's basically how we look at that.
Basically, to find these outliers, so we also use to cluster them down because you don't have so many exact routes.
Yeah.
Different cities, because this is like that. Private jets. People just want to do that.
Yeah, could be. Yep. See what happens? See? I love these guys, man, dear. So here's a quick thing I want to just summarize what you guys were talking about for a second, and this is actually critical to understanding back to the architecture, how you do things, is that transformation of the data is super important. And you might take a data set and another data set, another data set, but you're trying to get to something that has the features, that has this clustering, that has the principal components that actually are what you need to bake into the models so that you can actually get the answers that you want. And it's somewhat trial and error, where you realize that, hey, we're at 90-something% right now, or it's even worse than that, then you're like going, we don't even know how we can do this because there's too many classes of data here. So you might summarize the data, as Adine was saying. So part of this whole game is to, one, hire people like Symphony and Adine. But the other thing is to iterate, to actually figure out what your goal is and then be able to kind of curate the data and transform the data to get it into the form that would then put you into that space to answer the questions. Cool. It was good. It was great. I like it. Yeah, well, I did my best, I told you I was going to lie and wave my hands, right? I know. By the way, I noticed that, and you're getting a beer later. So, questions? Oh, there you go.
How fast can your model actually readjust?
Mm.
Someone mentioned the not annual events. For example, a concert happens,
Mm-hmm.
and on the day when it is on Facebook, I don't know, a lot of people actually buy tickets.
Mm.
How does your model react on a huge peak from the standard behavior?
Right.
How fast is it?
So, I think there's two questions there, which is really when you think about the burning of a new model, some of the models can take 2 weeks to burn, right? So that's not going to really respond to what's happening in an hour, so for sure. So I think the other question is really about anomaly detection and handling anomalies, right? And this is back to, there's a huge amount of research in this particular field for sure. So, but some of the things that we do is we will take let's say the 15 years worth of data, right? We'll take maybe 3 years of it at a time, and we'll start playing it against each other. So we'll start to say, if this was your training set and this was your actual input sets, and then you look at the results, and then you compare essentially the models that generally get the best answers, right? It's kind of like a voting system. And then you have software that takes a look at all those different permutations of building models, and then the accuracy. And I mentioned that there's the sort of the mean versus the standard deviation. So then you will pick ones that actually work really well for the use case you're trying to predict. So for the largest aircraft, operator in the world, they had a very specific use case they were trying to solve. So of course we could rail it to that. And we knew that from historical data what it was like. So we were able to kind of give them models that were able to handle the spikes when they happen. So, but so, yeah. Hundreds. So this is a great question. So the question is and this is something that comes up all the time. So I give a lot of talks to investors that I'm trying to get money out of. So any investors, write me a check. So basically, how many models do you need? So let me give you a really concrete answer to how to think about this problem. If you only have one model, right, you probably aren't going to get too far, right? Because it's kind of like input and output. Right. And so what ends up happening is people keep thinking like that, though. They want to build bigger and bigger models. They want to throw more stuff in to get better accurate results, et cetera. I tend to think AI is a combination of algorithms, software, knowledge bases, expert systems, and hundreds and hundreds, if not thousands of models. And what we did at Amazon, to give you guys a flavor of this, is don't worry about how many models you have. Have thousands of models. It's not a problem, right? Not today. Right, used to be when we did Amazon, by the way, all those cool tools like SageMaker, well, You're welcome, right? That's what we had to build. It didn't exist, right? So, but now you can have hundreds and hundreds of models, and you can play them against each other. You can do all sorts of things with them. So in a working system, once you have hundreds of models, and you could draw a box around that model, maybe you burn a model that kind of comprises, maybe some of those together. So you can do that as well, but don't be afraid of having too many models, right? That's not, and do hierarchies of models if you think of it like that. See, it's Adine. I say, dude. And they're like, dude, we need lots and lots of models, man. But yeah, so part of it is take the, what is the end result you're trying to get? So all the questions you're trying to answer and the nuances of the questions you're trying to answer. And that will dictate, just think of it like for every one of those outputs, just have a model. And so one example would be for every customer, every operator, instead of having one model that kind of like predicts what they're going to do on mass, why don't you have a model for each one of those guys?
Maybe for each one country.
You could do one for country. Yep. So one of the things that I freak these guys out about, because I don't tend to think small, since I'm not doing the work, right? I tend to think big. It's easy, right? Sorry. But I was like, why don't we just do all possible airport combinations in the United States and in the world? Why don't we just burn all those models, right? And of course, everybody screamed like you're an idiot, right? And of course that's true, but I still want it, right? So that's where Dean came up with why don't we just do, we'll kind of do regions, It's the south of, United States or south of Spain. We'll try it. How about we do that first? Okay, sure, do it first. But that's the answer to that, I think, is you'll once you have 50 million a year to burn on these things, right? You can always expand the scope of these things. So, but you do have to build something quick, and you have to be clever about it for sure. Does that help? Thank you. I have so much fun with you guys. This is great. All right. Oh yeah, sure. I know. I believe you. Mm-hmm. So so there's I think two pieces to what you're saying. Like, how do you handle malicious attacks on a system? That's one thing, and I would answer that one way. I think what you were saying is like, how do you prevent abuse of the model? Maybe it's like because somebody figures out that your model can do certain things, and they purposely feed bad data to it. Damn it! Right now, now I understand why you guys wanted me here. Dang. Okay, you all want free flights. I get it now. So yes, gaming a system, the way I would normally handle that is, like I said, I ran device security for Netflix for a while, and there's a lot of ways of handling attacks. And one of the things that, as a general comment for everybody in the room, security is actually super important, okay? And not just, as we're talking about somewhat maybe esoteric thing here, think of it in more holistically, right? So what can be gamed in a system is super important. If somebody can feed data into a part of your system that you did not intend, you have to really identify that, because that's where a lot of these attacks come from, is the ability. Like, you guys been paying attention to like Intel, you've got these like amazing like meltdown attacks and crap like that. So, these are very, when somebody's got like a lot of money and nothing else to do, right? They just go find these kind of things, right? So somebody attacking my systems, right? They will find a way in. So generally speaking, right, I isolate things. And so there's a concept of kind of least privilege. And so don't allow anything to touch your models that really aren't controlled by you. So you can do this now, guys, with AWS, other systems like that. You can isolate things down so that pieces of your system can only talk to other pieces of the system. And it can be very efficient, but then somebody that breaks into your system to try to get at and game your system, right, they have to go through door after door after door. And that leads me to the next thing that you absolutely have to do is get telemetry on what's going on in your system. So Netflix, 400 million devices in the world out there running at any particular time. I had a big problem, right? I have a lot of problems, but that was a really big one, right? And so what we ended up doing would be influencing the industry that produces the devices so that they would put security in from the beginning into the chips. So all the chip makers out there in the world, making sure that the security is there. So you build it up from that way, and then you need something that can actually detect when something is not going right. And again, you need the hooks from the beginning to be able to do that, because the first thing that a hacker does, how many are out there? First thing you do, what's this? Yep. So you get into that system and you hide yourself, right? And then you do your best not to perturb the system, because the minute that I know you're there, then of course I can go get you out of there. I can antivirus you. I can go in and figure out how you got in. So I'm not sure if that answered your question whatsoever, but it was fun talking. No, no. Was that close? You guys are awesome. So, but seriously, was that kind of, it was close? I'm happy to talk more about it, obviously. So, anybody else? I knew there was another hand. There you go.
Actually, 3 more questions about machine learning.
Do one at a time. I'm old. I told you guys I was old. Okay.
What supervised model do you use? Do you perform also feature engineering? And how do you scale your inference with your problem?
All great questions. So I would say the first question, what do we use? All the above. So, and I would recommend you guys do the same thing, right? There's great tools out there, Python tools, for different ways of building models. There's XGBoost and all sorts of cool things that you can do. But you can also go get SageMaker, right? Take your data set, give it to Amazon and say, well, you burn that. I don't care how you do it. They'll take 6 different, models or whatever, the best they can do, and they will come back with an answer that is the best that they can do. But what we have done over time is not only use everybody's, but we've started honing in on the best models and the best way to build models for the particular situation. And so for us, the answer to the question about feature engineering, that's a key piece of this. Absolutely. Once you realize that your models aren't working very well, they give you it's like a random noise generator. You get 50% yes or no, and it's whatever. But you need to be able to understand why is it doing that, and then potentially give it better data, which is back to the feature engineering. Like we were talking about flights. Well, maybe knowing what region it comes from is super important. Maybe the time of day, morning versus afternoon is really important. So if you think about machine learning, right, you take a date as an example, you can pull features out of that, like I said, time of week or day of week and things like that to give it more accuracy or better, for the model. And that's kind of how you might go about figuring out what features you need. The tools right now are super, they're very sophisticated. So you can give it a bunch of features and it will come back and say, these are the 5 that actually mattered. Right, and so I would recommend kind of going about it that way. So, but don't get locked into one way of burning models. That would be my recommendation. I mean, Adine, I don't know. Would you guys agree with that? Don't get locked into sort of burning one way or one type of model. You have to experiment. Yeah. Does that help? Did I get it all? There's 3 things. 1, 2, 3. Oh, and scaling. So that's another thing that from the way we're looking at this, again, you could use AWS like SageMaker to scale. So that's a simple answer to this, right? You could actually just have somebody else do it for you. We're going to go different routes, more likely, and we're going to basically be having, since we're doing something slightly different with continuous optimization, continuous burning of models and finding out the best ones and deploying them ourselves, we're going to probably use containers for that, and the ability to have APIs that you're just going to swap in a new model. And you might want to just inflict this new model on a small subset of your population. So we need a little bit more control over it. So scaling is actually very easy now, guys. You should never have a problem with scaling stuff except maybe for money. But AWS, EC2 instances, Docker containers, all of that. Does that help? But happy to keep going on that, though. Let me know. There you are.
And then we have a model.
Yeah.
So can you tell us more about the process of evaluating that model in production? So what is the target model? What type of things you are checking?
Yeah.
What are the important things
Right.
that affect your evaluation of the model? Is it better than the previous one?
Right. So I think that the broader question, just to start with, is if you think about training models, right? So you've got data input, and you burn your model. You've got a model. You put it into production, and like with Alexa, the first thing that happens, it doesn't work at all. It's supposed to be like 90% accurate. It's like 25% accurate, right? So obviously, once you have a tool to evaluate it, you would never put that model into production, right, if you had foresight about the data. So the thing to do is to actually find a mechanism by which you can capture the results. So if we take a look at Alexa, the big problem we had was Alexa was not in people's homes. So we were never collecting real-world data. But that's why I leased houses and I built these rooms. I know it seems crazy, right? But you got to get that data so that before you put it into a customer's hands, you have a pretty good idea. So the clever bit really is to figure out how you're going to get that data. That's the first simple answer maybe to the question. And in the case of Alexa, right, when we actually were deploying these things, it wasn't just one thing. So that's why I said it kind of depends. So let's take a look at Alexa for a second. So music was a very important use case. Jeff, remember Jeff? Really wanted to have music. But he also wanted shopping, and he wanted timers, and he wanted everything, right? He has an amazing mind, and he wants a lot of stuff. So, but it turns out the models for for music versus shopping, music was super easy. Catalog of music, catalog of artists, catalog of everything is fairly static, doesn't change a whole lot. The words used in the titles are somewhat regular, more predictable, whatnot. But when you go shopping, it's I want to have a Barnes & Noble t-shirt. It's that might be not anywhere, right? So the ability to take a look at models and what the use case is, and knowing what the customer needs as the accuracy was a thing that we had to learn, is that not all models need to be at 95%. In fact, you might have it at 80%, and it actually solves the problem. So you have to have a target. So you have to be able to collect the data, figure out how to collect the data, and then you need to have a target that matches the use case somehow. And so for us, with respect to shopping we knew ahead of time, we needed shopping to be really high, because we wanted to make sure that we were able to give you some high quality answers. But music, it turns out that if you ask for some I don't know, Bonnie Raitt or something like that, and we actually give you something kind of close, maybe you listen to it and you're kind of happy. So maybe that wasn't, didn't need to be 95%. So I'm kind of just giving you a sense of how do you know how to do this, and when do you burn new models, and when do you deploy new models. And so every single time it's going to come down to the use cases. And if you don't have users telling you, well, I should take a step back. If you don't have users, you got to find a way. Told you about that. If you have users are unpredictable themselves, right? So you have to find classes of users that you can inflict this on and watch their behavior. And so again, you need a way of watching their behavior. So we have population X that's getting this result, population Y is getting this result with a different model. And you can compare and contrast those. And it's really hard, especially if the data, you must know this. If the data is somewhat you don't have enough data, you need to find a way to get the data, because it will be kind of this hunt and peck for a little while. So, by the way, guys, when we developed Alexa, the Echo device was done years before, right? I mean, we knew what we were going to do on that, but the ability to actually launch a product, we just sat in a room with this thing and it's would you use it? It's no, it gets it wrong 2 times out of every 10 I use it. Well, that's 80%. Well, how much do you need? So what we did, and this is going to freak you guys out because I do crazy shit, right? So I shouldn't have said that, it's on video. But sorry. So what we did is we literally gave people okay, here's your device right in front of you. It's got a speaker and it's called Alexa. Talk to it, ask it questions, right? And so you talk to it, right? And lo and behold, that thing talks back to you. You say, well, I'd like to buy a t-shirt or whatever it is. And it said, well, that'll be $14.95 from this, it's got whatever. And you go, and it says, do you want to buy it? And you say yes. And it says, okay, I'll do this on your, your Amazon account, right? Well, we totally Wizard of Oz this thing. And what that means is there was a human on the other side behind the curtain that was listening to you, and she was talking back to you. And what we did is occasionally she would give you bad answers. You'd be oh, and I want to listen to Bonnie Raitt. And she goes, all right, Dire Straits. And you'd be no, I want Bonnie Raitt. No problem. We'll do blah, 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 Bob Marley. And so what we did is watch people's reaction, and then you could kind of gauge the level of accuracy you needed. So again, you have to find ways of getting the data, especially when in a product that is brand new. Nobody had data for this stuff. So I don't know. Was that entertaining? Maybe didn't answer your question. I don't know. Cool. More? Oh, come on. I got hours left in me. Come on. And Kennan's going, yes, he does. Shut him up. Take the mic away. Take the mic away. Oh. No, this is great, you guys. I really appreciate you taking the time. Very thoughtful questions. I'm very happy to talk to you guys afterwards. I think I see that there's a bunch of people in the crowd that know quite a bit about this, probably lots more than I do. But at the end of the day, what I'm trying to present to you guys is Go after your dreams. Think of really big things that you want to do, and don't get discouraged. You know, the people that you may need to help you with that dream are all around you, right? So think about what you want and go after it. So I'll leave you like that, unless there's no more questions. Yeah? Yeah? All right, let's do it. Woo! You guys are awesome. Woo! And Symphony! Symphony! Cool. Oh, yeah. Oh, hey, guys. Whoa. Who wants a selfie with me? Oh, be honest. We all do. I'm going to do it maybe from over here. Let's see if I can get this. I was just telling people that I'm super narcissistic. Oh, yeah. Let's, well, you know what? We might have to do two. I don't know. All right, guys. Here we go. All right. You guys, if you want to be in here, you got to get that way. And you guys got to go that way. And you guys got to go that way. All right, here we go. We're gonna do two, okay, guys? Woo! All right, woo! Here we go. One more. Here we go. Keep going. You guys got to wake up. What's going on? Woo! All right, you guys. Thank you so much. It was a pleasure. Cheers. Woo!